at it this way.
Can I empty this?
Alright, so today we are going to work on lesson 1.3. Your notes can be in front of you. Our lesson is over prime factorization. Today our learning goal is up here on the board. It's also on your notes. It's also going to be in your planner. And it should also be in your workbook that we'll look at. But the goal is that I will write a number as a product of a prime factors and represent that product using exponents. Once again, we always want to make sure we understand what that goal means. So, today, if you would write this on your notes with me, I'm going to say the number 20. So, what this is telling me is that I'm going to take a number, which we made the number 20, and I want to write it as a product of prime factors.
Can I open this?
How do you open this? If you disconnect this first. You just go dump that. So my number is 20, and I want to write it as a product of prime factors. To do so, I would just copy my notes, and we'll work on this in a little bit. I'll explain it more. But I'm going to write down and that is my answer. 2 times 2 times 5. That is going to be your goal today. You could take a number and you're going to write it as multiplication of prime numbers. If I did 2 times 2 times 5, I would get 80. 2 times 2 is 4. 4 times 5 is 20. Okay? Now, the first thing I need you to do, I'm going to steal your book, Patrick, just for a second. I need you guys to open up to lesson 1.3 in your workbook for me. Lesson 1.3 in your workbook. Page 11. Thank you, Sky. Lesson 1.3 says prime factorization for use with exploration 1.3. That is exactly what we're doing right now. There's our learning target. Our success criteria. How are we going to make sure that we are successful today? 4 ways we're going to do that. The first thing, I can find factor pairs of a number. That's going to be a key word here. We're going to talk about that here in just a second, what factor pairs are. But one thing you have to do is find factor pairs. The second thing you have to do today is that you have to tell me what prime numbers are and what composite numbers are. We actually talked about those in lesson 1, I believe. I already made a poster. We'll further discuss it. On the third one, I can create a factor tree to find the prime factors of a number. That's what we're going to do here in just a second. And then I can write the prime factorization of a number. That's how you write your answer. The last two go together. I get the fourth one. I write the prime factorization by creating a factor tree. And I think a factor tree is very, very simple. Okay? It's just using your math facts. So, on the first one, it says work with a partner. Your partner is going to be your whole table group. It says 2 students use factor trees. Okay, this is how you guys use math to help yourself. If they just told me they made factor trees, here's a factor tree, there's a factor tree. This is a factor tree that's shown. You should start trying to figure out what that is. To write 108 as the product of factors. Product of factors is what our prime factorization is. That's what we're trying to get to. Student A, they said 108. they broke it into 2 times 54. What is 2 times 54? Yeah, so they just broke it into, they said instead of saying 108, I'm going to say 2 times 54. It means the same thing. Instead of saying 54, they said 2 times 27. And then they said, so if I'm writing the prime factors, the product of factors, the prime factorization, they said 108 would be written as 2 times 2 times 27. Now if I use my calculator and I do that, 2 times 2 times 27, I get 108. They're absolutely correct. So they did it in 3 factors. Student B said, 3 factors? Yo, I can do it in 4. They took 108 and they said, I'm going to do 3 times 36. Does 3 times 36 equal 108? Yeah, it does. They took 36 and they said, I'm going to change that to 3 times 12. 3 times 12 is 36. They took 12 and made it 2 times 6. 2 times 6 equals 12. So they said 108 is now 3 times 3 times 2 times 6. 4 factors. Here's your job. On A, I want you to try creating a factor tree. You're going to use 108. You cannot use the number 1 as a factor, so you can't say 1 times anything. And can you write 108 as a product with more factors than everyone else used? Yes, you can. I'll give you this hint. There's 5 factors. The final answer should be 5 factors. If your group can find the 5 factors and explain to me, everyone in your group knows how to get to it, you get 2 links bucks a person. First group. Oh, make sure everyone in your group understands. Ready? Begin. Thank you for letting me borrow it. Okay, we're back together. I'm having nothing but problems with technology today, so I have to do it on here. I can't pull it up on the thing. So, first thing, 108. My first group was over here. So 108. How did you break it up?
Okay, so we broke 108 into 3 and 36.
3 times 36. Okay.
And then we broke 36 into 3 times 12. We then broke 12 down to 2 times 6. And then we broke 6 down to 2 times 3.
Okay. And what was your answer?
108.
They've already used it.
Okay.
Oh, no, like the factors.
Yep. What are the factors then?
3 times 3 times 3 times 2.
No.
3 times 3 times 2. 3 times 3 times 2 times 2 times 3. Oh my gosh.
All right. Now, to be honest, that will work. But typical when we write our factors out, we put them in numerical order.
Yeah.
So I would say 2 times 2 times 3 times 3 times 3. Now, I'm going to tell you today, that is how you have to put in your textbook or in your answers online. You have to use the multiplication. When you click on it, you have to say 2 and then hit times 2. Don't hit the X on your keyboard. You do that, it counts as you're putting the letter X in. And so it will not accept it. Okay? Now, did anyone else, you guys get this, and I'll give you your links box in a second. Did anyone else get this?
Yeah.
You can't get it in. What do you mean a different order? Okay, that's fine. But did you do it the same way? Okay. Anyone else do it a different way?
Wait, if she got 3 times 3 times 3 times 3 times 2.
No, we did not say that.
No, she got 3 times 3 times 3 times 2 times 2. So she got the same factors. Now hold on. Sarah, you said you have the same answer, but you did it different? Well, let's check.
No, really did.
I think you're lying to me.
Then I probably am.
Well, let's see. What did you break 108 into?
So a lot of different groups were doing the 3 and 36. So then I decided I would try to do it the 2 and 54 way. So 2 times 54, and they broke it into 2 times 27. And then so then I broke 27 find 5 factors.
Okay, so here's my question. She gets it right. 2 times 2 times 3 times 3 times 3.
Oh,
Does this mean, is there multiple ways to get to the answer?
yes.
Yeah, there's actually a lot of ways to get the answer. How come there's only a total of 5 factors? How do I know there's no more than 5 factors? How come I don't have you guys work for 10 more minutes and say, can you find 6 factors?
Yes. No.
I could give you guys till tomorrow. All you do is work on math. You would never find 6 factors. Why?
Because you can't divide 3 by anything without making it a fraction or a decimal.
Awesome. What is the number 2, 2, 3, 3, 3? What do they all have in common? What are those numbers?
They're all prime.
They're all prime numbers. What are prime numbers?
Numbers that can only be like, I believe it has a factor by itself in 1 or something like
Good. If you look up here, I actually made the poster. Prime numbers. Numbers with 2 factors. 1 in itself. Means if I was to break the number up evenly, the only numbers that go into it that I can divide by is 1 and the number itself. A composite number means it has more than 2 factors. Now, here's our prime numbers. 2, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37. Those, did I mess up on one?
29. It can be 1 times 26.
No, 3 times 7 is 21. So, we have different prime numbers. And it goes on for a long time. The bigger the number, usually the bigger the gap in between prime numbers. Composite numbers have more than 2 factors, such as the number 8 has 1 times 8, 2 times 4. So it has 4 factors. The number 12 has the factors of 1, 2, 3, 4, 6, and 12. The number 9 has only 3 factors, but it's composite. 1 times 9 and 3 times 3. So 1, 3, and 9. When we do this, one thing you should do, and if you didn't do it in your workbook, you might do it now because it'll help you greatly. I hope you're following along so you don't have questions on today's. I would go ahead, when I break this up, I draw a box around my prime number. I draw a box around my next prime number. And when I get done, I should only be left with prime numbers. If I do not have a box around it, it means it's a composite number, which means I should break it down. I'm going to use blue to show this in just 1 second. Now, this is where we got our answer, right? Well, could I have went a different route? You guys already showed me I did a couple ones. But let's say I went to 108. What if I would have broken 54 and I went this way instead? Instead of doing 2 times 27, what if I did 6 times 9? Doesn't 6 times 9 equal 54?
Yeah.
Okay? 6 is a composite number. So 6 times would have been 6 times 2. 6 times 3. I about wrote 6 times 2. Or 2 times 2. I better write this nicer. 2 times 3. Which means 2 is prime. 3 is prime. The number 9 is composite. So I would have made it 3 times 3. And those are prime numbers. And if we look at what we have left, we would have done 2 times 2 times 3 times 3 times 3. We would have got the same answer. What we are going to look at right now is the number 2 and 27 that make up the number 54. Number 6 and 9 also go into 54. So if we focus only on 54, and I say the word factors, I'm going to write up here on the board. if I ask you for the factors of 54, or I'm sorry, 54, what are the factors of 54? You could say 1 and 54, 2 and 27. Ooh, man, I'm going to have to spread this out. 54, 27. Let's see, 3 and 18. 4 doesn't, 6 to 9, and then that'd be it. So if I ask you for, hey, what are the factors?
Wait, 7 and 8 equal 54.
No, 7 times 8 is 56.
Oh,
Alright, so if I ask you for the factors of 54, you would simply say, what do you let Asim? Just pull the door, Asim. You would simply just say 1, 2, 3, 6, 9, 18, 27, 54. Okay? It's pretty easy. Now, if I go to Dick's Sporting Goods and I give this shoe that Ethan so willingly volunteered to me, so I take his and I take mine. Now, when I go to Dick's Sporting Goods, I go and buy shoes, and they call it a what?
Manager.
A blank of shoes. A search for the
Garage.
a pair of shoes. Ever.
Pair.
I need you to be serious with me.
I actually thought it was garage. Because I thought, no.
Okay.
In my ears, I heard it started with a B.
Okay.
I know.
Now, if I go to Dick's Sporting Goods and I want to buy a pair of shoes, right? So I go in there and they go, I was like, I need a new pair of tennis shoes. They go, all right, sir, here you go. You got this one and we'll give you this one. So they give me the one I had on and they give me Ethan's. One, they're not the same size. They're not even the same brand. These are Nike, mine were Skechers. They don't look the same. How's your smell? How's mine smell? How's mine smell? Ethan smells funky. Mine smells nice and fresh.
Ew.
Ethan's like, oh, you stinky. So, now, I have these. Would they sell me these two? Would they put these two in a box and give it to me?
Yeah.
No, because these are not a pair of shoes that go together. Okay? These are just two shoes. These are not the pair of shoes that go together. A pair of shoes would have to be like both these Skechers. They give me both of them. And the reason, go ahead, have your planner out. You're being disrespectful and interrupting me having your own comments. So I have pair of shoes. They give me both the same size, the same brand, same color, and they give these to me. And the reason is, now I can take those shoes and they match for me. When I wear them, they serve their purpose. They fit my feet, and they're the same brand. We are going to work with factor pairs. So, if you would turn quickly to your notes, put your workbook to the side, and we are going to look at factor pairs and what these are. So, based on what we just did with pairs of shoes, we're going to look at what a factor pair is. Now, a factor, of course, is any two numbers that multiply together. Math and static. I hope you guys are paying attention, not just playing with the calculator. So, this factor pair, if we think of factors, they are numbers that multiply into another number. When I ask about a factor pair, though, it's two numbers that are going to go together for a purpose. They give us a given number. We did the number 54. Can anyone think what a pair? What is a factor pair of 54? Which two numbers do you think go together? Ethan?
96.
Yeah. 9 and 6 are those factor pairs of 54 because 6 times 9 is 54. If I would have chose 6 and 18, those are factors of 54, but are they a factor pair? No. If I put 6 and 18 together, I get 108. Well, that's not what I needed. What's another factor pair of 54? 2 to 27. Another factor pair. Sit up in your seat, please. Put the calculator away. We don't need it right now. Alex? 54 and 1 are factor pairs. 3 and 18. So, first thing in our notes, we're going to identify what factor pairs are. So, factor pair, right here in my notes. How do you think we could define it? Okay, so I'm going to say factor pairs. 2 numbers I'm going to say multiplied together to give a certain, or I'm going to say specific, number. You writing this down in your notes. A factor pair are simply 2 numbers, or you can even say 2 factors, that are multiplied together for a specific number. So let's do a quick game while you're writing that down. With my infinity ball. Don't let it ruin a planet. But can anyone identify a factor pair for the number 12?
3 and 4.
3 and 4 is a factor pair. Any other ones?
1 and 12.
1 and 12. 2 and 6. How about for the factor pair of the number 10?
2 and 5.
2 and 5 are factor pairs.
10, right? 10 and 1.
10 and 1. How about factor pairs of the number, ooh, I'll do a harder one, 100.
10 times 10.
So 10 and 10.
50 times
50 and 2.
100 times 1.
1 and 100.
4 and 25.
4 and 25.
100 times 3.
100 times 3, give me 300.
3 had,
There's, I don't think we did 2 of them.
5 times 15.
Ooh, not times 15. 5 times 5 and
20.
20. Nice job, Patrick. 5 and 20 and did we do 2?
No.
Oh, 2 and something.
Yeah, we did 2.
Yeah, we did 2.
Did we do 2?
Yeah, we did 2.
So we did 1 and 100, 2 and 50, 4 and 25, 5 and 20, 10 and 10. Now, let me ask you this. Was that kind of hard to, I mean, it wasn't hard, but was it hard to know whether we had them all?
Yeah.
Like even now, I swear to you, I'm not even making this up or playing. I was really trying to think, did we get them all? What did you say? And the reason it was hard to identify all our factor pairs was because they were just random. We were thinking. So, we're going to do this real quick. On your notes, turn your notes sideways. And let's write down the number 24. Alright, for the number 24, Leon, I hope you follow along. Do these notes with us, bud. To help us find all the factor pairs of 24, I use a method called the upside down rainbow. Okay? It's very important. Here's how you do it. You're going to leave big gaps. I identify the very first and the most easy pair of factors, which is always 1 and the number itself. So I leave a big space in there. And what I do with the upside down rainbow is I'm going to connect them with this little loopy line. So it makes like a rainbow that's upside down. Leon, I need you to put that away and please focus on your notes. So I have 1 times 24. Now, I'm going to show you the way, especially for some of you that don't feel like you know your math facts very well. This is how you use your calculator. With the upside down rainbow, we use simply the number line. The first number is 1, and 1 always goes into it. What comes after the number 1? 2. So all I have to do is check the number 2. So if you didn't know your math facts, you would type in 24 divided by 2 equals 12. So is 2 a factor of 24?
Yes.
Yeah, but what is its factor pair?
12.
So its factored pair is 12. So I do 2 on one side, 12 on the other, and we connect them. Do you notice how the 2 lines connecting them never touched? It's kind of like a rainbow. It's going to fit right inside of them. That is going to prove that I'm getting these in order and that I got them correct. After the number 2 comes the number 3. So 24 divided by 3 is?
1.
Oh, it's 8. 24 divided by 3 is 8. So 3 must be a factor. 3 matches with 8. After the number 3 comes the number
4.
Okay, so 24 divided by 4 is 6. So since it came out to a whole number, 4 and 6. Once again, my numbers have not crossed at all. After the number 4 comes the number
5.
Okay, so 24 divided by 5 is 4.8. Can I use that?
No.
No, we're looking at whole numbers only. So 5 I don't write down. It's not part of a factor pair. After the number 5 comes the number
6. You already have
but I already have that. So once I get to whether I already have the number or its factor pair is bigger than what I started with, I just say halfway, I'm done. All the factors of 24, if I asked you for the factors of 24, you would say 1, 2, 3, 4, 6, 8, 12, 24. If we ask for the factor pairs, 1 and 24, 2 and 12, 3 and 8, 4 and 6. We now know, just by checking 5 numbers, all we did was check 5 numbers, 1 through 5. Once we did that, we had every factor of 24. Yes?
I'm just making a comment.
Sure.
You kind of sound like the guy from Brain Games.
That's awesome. I was smart. All right. So here's what we're going to look. Turn your paper sideways again. And I'm going to show you this first part. On example 1, it says finding factor pairs. This is when we would need to know what our factor pairs are. And I'm going to show you how you can break up story problems. How many people hate story problems in math? Dude, I do. Story problems, it's reading. It's a different kind of, we do reading in math. We read graphs. We read equations. We read problems. But when I look at this and it's a paragraph, it's like a story, and I'm like, I don't really like that. A real reason a lot of times in math we give you stories is because how we can make them relevant to other people. I'll use names from their backgrounds or their culture or their religions, or I'll tell a story about a place from there. But to be honest, in math, we don't care. Math has to do with numbers. So I'm going to show you what I'm going to highlight as we read. It says, The brass section of a marching band has 30 members. So far, the only thing I cared about in that sentence was that there's 30 members. In my head, I'm thinking I have 30 of something. The band director arranges the brass section in rows. Okay, I'm going to have rows. Each row has the same number of members. Each row, same number. How many possible arrangements are there? How many arrangements? To be honest, everything else in that paragraph is fluff. I do not need it. All it does is distract me. So all I do is I look at this again. I'm going to say, okay, I have 30. I'm going to make 30 objects. I'm going to put them in rows. And every row has to have the same number in each one. So I can't go 5 and 6 because that's not the same number. Every row has to have the same number. And I want to know how many different arrangements can I make. Okay, so how many choices can I do? This is where we use factor pairs. We look at the number 30, and I say, okay, well, what are the factor pairs of 30? I can do 1 times 30. That's my factor pair. Now, does that count as one arrangement or as two?
Two.
Why would it count as two? Because 1 times 30 is the same as 30 times 1. So why would that count as two arrangements?
Because one row of 30 is every kid having their own row, and 30 rows of 1 is list all the kids lined up in one row.
I think you said that backwards, actually. 1 row of 30 means everyone's sitting in the exact same row. 30 rows of 1 means one kid's in a row, the next kid's in the next row, and then the next kid's in the next row, and we have 30 of those rows.
Oh my gosh.
That is different. If you think in our classroom, if we make 1 row across here with 21, or if I make 1 row with a kid in each one, I'd have to have 21 rows. My lines would go down the room this way. So that's worth 2. The other factor pair, 2 times 15. So I could do 2 rows of 15, or I could do 15 rows of 2. I have 3 times 10 is a factor pair, which means 3 rows of 10 or 10 rows of 3. 5 times 6, I could do 5 rows of 6 or 6 rows of 5. And then the reason I don't have to do this other 6 times 5 is because we've already done it. So if I count my arrangements, I'd have 2, 4, 6, 8. 8 arrangements. Okay? The biggest takeaway I need you guys to take from that is if I look back into my notes. Oh, I don't have it on this one. Oh, it's on my OneNote. If I look back into my OneNote, that criteria, I'm going to pull it up so I can see it. I know you won't. My first one is find factor pairs of a number. That's our big takeaway. Can you do this? 24 and list the factor pairs of it. Can we do 54 and find the factor pairs of it? That is the biggest question. Okay? Let's move on to the next part. This is the one that's a little more tricky. Oh, let's do the try it. Let's do the try it for number 18. Do number 1 and do number, well, we already did number 2. Ooh, let's do this. I gotta give Lynx bucks. I want you to do 18 and then do number 3. Number 3 is going to be worth a Link buck because I don't know if you can get it. Okay, I'm gonna pause. Coming back together. So, factor pairs of 18. Let's turn this sideways. We'll see if we can get them. I'm going to do 18 right here. Who thinks they have them?
8 and 2, 9 and 2.
Okay, so you said 9 and 2. Is that all of them?
No. That's all I got so far.
Nope. That is not all of them. So I'm going to come here and I'm going to say, he did say 2 and 9. That's 1. Can you steal? What could be my other ones?
1 and 18.
Hold on. 1 and 18 for sure. 2 and 9. And what'd you say? 3 and 6. Is that all of them? Let's check. 1 times 18 is 18. 2 times 9 is 18. 3 times 6 is 18. 4. 4 times 4 is 16. 4 times 5 is 20, so no. 5. 5 times 3 is 15. 5 times 4 is 20, so no. 6.
Already have it.
We already have it. So the pairs are 1 and 18, 2 and 9, and 3 and 6. Awesome. You get a steal. I will give you your points in just a second. All right, let's go to the harder one. 51. Now, I'm going to be honest with you. If you use my method, I think you could have got this. For some of you that didn't, I doubt you get it.
I know 2.
All right, what do you have?
The first one, well, there's only 1.
What is it?
1 and 50. No, it's not 1.
Mason?
So there's 1 and 51, that is correct, and then there's 3 and 17.
Yep. I'm pretty sure we
Now,
followed them.
3 and 17 is correct. I would have checked, this is the way I would have done it. Doing that upside down rainbow. We know 51 and 3, or 51 and 1. I would have done 51 divided by 2. Doesn't work. 51 divided by 3. 17. That one works. So that's a factor pair. 51 and 4. Doesn't work. 51 and 5. Man, am I going to have to check 100 of these?
No.
I did 5. 51 and 6 gives me 8.5. 8.5 still more than my 6, so I got to keep going. 51 divided by 7. 7 point. Now look, I did 7 and I got 7.2. They don't work, but isn't 7.2 really, really close to 7?
Yeah.
It's still on the opposite side of my rainbow, so I'm going to check another one. 8. Now, did you notice that this one was 8 on the left side of the rainbow, but 6.3 would have went left of my rainbow? Because 6.3 is less than the 8 I was dividing by. That means my rainbow would have had to go backwards, which would cut across all the other ones. So that's how we know we are done.
I don't understand.
You don't understand the rainbow?
No, what you just said.
Okay, so this is what I was saying. If we did 1 and 51, notice how we draw that line? Correct? Okay, so if I did 3 and 17, we connect them. Okay? Now I'm going to do this in red because this one doesn't work. When we did 8, and we said it's going to be 6, well, 6, I would have had to go backwards.
Wait, but you could make the 8 in front of it.
But we can't because we've already checked 6, remember? So when we work left to right, every time our rainbow is going left to right. Now, if I would have said 8 and I said 6.2, we would have went back to the right, or to the left, I'm sorry. So we went the opposite way. But you could, but here's the thing. I get what you're saying. You could have said, well, I could have just said 6.2 and 8, right? However, that's not a whole number. We did the number line. We said 1. We said 2, 3, 4. Why do we write this 8 right now? To show you that I'm going the wrong way.
No, like, just tell me.
All right, so watch this. When we do this, we use the number line, right? 1. Does 1 go into 51?
Wait, but why did you bring up 6.2 if we're using whole numbers?
Because that's, okay. The reason we said 6.2 was we checked 51 divided by 8. And when it got 6.2, the reason I'm bringing it up and saying, the reason I'm bringing it up is because that answer became smaller than what I divided by. When I get that, I know I'm done. If I don't, I'd have to check 9 and check 10, and check 11, and check 12.
Oh, I see now.
So when we identify that the answer is smaller than the factor we started with, we know we're done. We don't have to check any more numbers. Otherwise, you never know when you're done until we get to 17 to 3. Because you'll be like, oh, I already did 3, or I already did 17. All right. This next part, I really don't think you guys are going to have troubles with because we did it in our exploration. It is example 2, writing a prime factorization. Now, if I think back to where we were talking about our criteria, we've now identified factor pairs. We know what those are and how to get them. You know what prime numbers are in composite. So now we're working on our last 2 parts, which we need to finish in the next 10 minutes, so you guys can have time to work on your homework. Now, what we're going to work on here is creating a factor tree. Write the prime factorization of 48. In your homework, people are getting confused because they don't know what the question's asking you. If it tells you to write the prime factorization, or if it's asking you what is the product of prime factorization, or write the product of as many factors as possible, you're doing the same thing. You're going to make a factor tree till you get to the prime numbers. On this first one, 48. Every time, now make sure you're following along with me. Every time, all you have to do is ask yourself a question. Is the number prime or is it composite? If it's a prime number, circle it. If it's composite, you branch it off into 2 factor pairs. I should say 1 factor pairs, 2 factors. So like on 48, they said 48 is composite, so they made it 2 times 24. 2 times 24 is a factor pair. 2 is prime. I am done with that number. 24 is composite. What's another factor pair? Well, they said 2 and 12. Could I have used 3 and 8, 4 and 6? Yeah. Our tree would have just looked a little different. 12 is composite. So they did 4 times 3. 3 is prime. 4 is composite. A factor pair of 4 is 2 times 2. Those are both prime. And because I've circled all primes, I have nothing left to break down. So now, I don't want us to be tossing, Ethan. Otherwise, I get to toss you my pen so you can mark your planner. Really fun. So, turn, please. Your back should be facing the board because that's where all our work is. So then we write this out. Now I'm going to show you one trick that they did, but you guys are not going to write this on your homework. When they wrote out their answer, they wrote it smallest number first, 2 times 2 times 2 times 2 times 3. Now, we learned on lesson 1, when we have a number repeating itself, we make it the base. So when I see 2 times 2 times 2 times 2, I have 2 as my base, and since I repeated it 4 times, we put that as my exponent. And then we had a 3 left over, so times by 3. Now, to be honest, yes, that is the best way to do it. On your homework tonight, they don't want you to do that. They want you to write it all the way out. Okay? Draylee, are you focusing with me? Okay, because I hope you get 100% on your homework then and have no questions for me. All right, let's try this. I'm going to do one of these with you, and then I'm going to pause, and I want you guys to work. Let's do 20. Is 20 prime or composite? Composite. Raise your hand. Who can tell me what is a factor pair for the number 20? Everett?
4 times 5.
Sure. Could you guys have done something different?
Yes.
Absolutely. Is the number 4 prime or composite? Okay. If it's composite, who can tell me what are two factors? What's a factor pair? Alex? 2 times 2. Is 2 prime or composite? Ooh, I'm going to box it, which means if 2's prime, that 2's prime. I still have this branch. Is 5 prime or composite? Well, I'm done then. I have nothing to branch off because I've boxed everything off. So my answer is 2 times 2 times 5. Okay, I'm going to pause. I'm going to come around. I want to be looking at your papers. I want to see you do 6, 7, and 8 if you can. 8 is a tough one. All right, so we're going to do number 6. 88. Is 88 prime or composite? Mason? All right. So there's multiple ways you can go about this, but what are two factors that go into 88?
244.
Okay, 2 times 44. And we already identified 2 as prime. Is 44 prime or composite? Okay, so what can we break 44 into? What is a factor pair of 44? I heard 2. I could do a 2 in there. 2 times what? 22. 2 is prime. 22. 2 times 11. 2 is prime. 11 is
Prime.
So now I'm done. Because I got all primes left. All my numbers are prime. Everett, follow along. So I have 2 times 2 times 2 times 11. That is our answer. Talon, sit up at your desk. Next time I have to ask, I'm going to have to mark you down. It's the second time I've had to ask you. Okay, I'm going to skip 90. I'm going to go to the hard one. 462. Sarah, what's the first one?
Well, what I did was I did 2 times 231.
Sure. You can always use the easiest number you want. Now, when we get to 231, honestly, my opinion right away, I'm thinking that looks like a prime number. But I don't just guess. We use the number line. I already know 1 times 231. 2 doesn't because it's an odd number. So then I check the next numbers.
What I got was 3 times 77.
Good. If we were to use that number line, after 2 comes the number 3. And if I would have checked 3, I would have got 77. 3 is prime. 77, is it prime or composite? What could I do for 77, Sarah?
Divide it by either 11 or 7, so just break it up into 11 times 7.
And 7 is prime. 11 is prime. Which means my final answer is 2 times 3 times 7 times 11. Alright, last part we have to discuss. So that is making a prime factorization. Turn to your backside of your notes and we're going to go to this part. It says using a prime factorization. Now, this one we're not finding the prime factorization, we're using our factoring tree. You're going to take this to another step. It says, what is the greatest perfect square? So, the question here is saying, what is the greatest perfect square that is a factor of 1,575? Remember, a perfect square A perfect square was a number that was made by two numbers times themselves. So like 4 is a perfect square because it was 2 times 2. 9 is a perfect square because of 3 times 3. 16 is 4 times 4. Now, if I was to try this, the easiest way, or easy way, is if I had a small number such as, let's do 24. If I list all the factors of 24, 1, 2, 3, 4, 6, 8, 12, and 24. And the question is asking me, what is the largest perfect square? Well, is 1 a perfect square? No, we don't get to count that. Is 2, Talent, please have your planner out. I'm going to say it. This is your one word, and then you have to say the other word elsewhere. Is 2 a perfect square? Is 3 a perfect square? Is 4? 4 is a perfect square because of 2 times 2. Is 6 a perfect square? 8? No, it's 4 plus 4, but not 4 times 4. Let's do the safe seat, please. Take your stuff. Obviously, this is too much. I'll find a new spot for you for Thursday. Is 12? Is 12 a perfect square? No. 3 times 3 is 9. 4 times 4 is 16. Is 24 a perfect square? No. So in 24, the only perfect square is 4, so it's the largest. Now, we could do it that way. We'd have to list every single perfect square. We'd have to list all the factors. Do we want to list all the factors of 1,575? No. So here's how you do this shortly using prime factorization. We just go ahead and we find the prime factorization. So I broke 1,575 into 25 times 63. 25 breaks into 5 times 5. Those are prime. 63 is 7 times 9. 7 was prime. And 9 became 3 times 3. When we wrote it out, we get this. The prime factorization of 1,575 is 3 times 3 times 5 times 5 times 7. Now, I'm going to write this big, and if you want to do this in your notes, that'd be smart. I need you to get your stuff down. I'm going to move you also. Come sit up at the front. Please take the fan off that safe seat. That's your spot for right now. What I'm going to do with these numbers. Now remember, to make a perfect square, it's a number times itself. If I look at these 4 or 5 numbers, do I have 2 numbers that are listed at the same time?
Yes.
Okay, we have 3 times 3. Well, that would make a perfect square. 3 times 3 is? Okay, so 1 perfect square is 9. We also have 2 5s listed. Well, 5 times 5 is, what did you say?
25.
Now, I do not pay attention to the 7. The reason is there was only 1 7. It didn't have a pair. So 3 and 3 gives me 9. That's a perfect square. 5 and 5 gave me 25. That's a perfect square. I then take my perfect squares times each other. 9 times 25 gives me the number 225. This is my perfect square. This is my largest perfect square. You will have to do this today. There's 2 questions with this. So, once again, You take your number and you do what we've been doing. You make a factor tree and you break it all the way down till you get to prime factors. Then you look at your numbers. 3, 3, 5, 5, 7. Is a number repeated more than once? So is there 2 of them? When there is, I had 2 3s. I had 2 5s. I multiply it all together. I could just write 3 times 3 times 5 times 5. And the number you get is your perfect square. 225 is a perfect square because it is 15 times 15. The only way we could have written all these out and seen them is if I would have written all the factors out. Otherwise, facts of math, if I take a perfect square times a perfect square, the new number is a perfect square. The reason I see that, you see how I use 3, 3, 5, 5? 3 times 3 is 15. 3 times 3 is 15. They show the work right down here. 3 times 3 is 15. 3 times 3 is 15. So it would have been 15 times 15. And number times itself gives me a perfect square. Okay. For your homework tonight, I'm going to state this numerous times. You have to show all your work and turn your paper in. It is going to ask, find the prime factorization. That's making the factor tree. You have to show your work. You have to get it down to here, and you have to use multiplication. You don't have to use a dot. You can use the multiplication. If it says list as a product of all the factors, you're not listing the factors. You're doing the factor tree and listing all these numbers. Yes. Today is Tuesday. It is due Thursday. Oh, I decided during Life Ed I'm going to give you guys a different break. Your homework is always due that next Silver Day, but by 10:30. The reason is every other class would have the advantage of having a Life Ed class, where they could finish their homework and get it done before class. So I will give you guys the same advantage, because first day Silver, like first period today, they were able to work on their homework, today's homework, during Life Ed as well. Well, you guys don't get that extra advantage, so I will give it to you. So your homework is always due by 10:30 on the next Silver Day. So yours, today is Tuesday. I will see you on Thursday. Yours is due Thursday at 10:30. Okay, last thing before you start working. When you do this, your paper, I need to see name, date, Chapter 1, Lesson 3, assignment, and then I want you to tell me you are 4S, 4th block Silver Day. Okay, get started. You have the rest of the class. You still have about 10 minutes to work.